All right, so if you can turn to page 11 of your packet, what we're going to talk about today is shifting a trig function. And honestly, it's nothing new. We've already done this, right? We've talked about shifts in here. We know that when we add a number to the end of a function, doesn't it just move it up? And if we, let's say this was minus d, if we subtracted a number, right, from the end of a function, it just moves it down. All right, so let's take a look at example 18. It says, on the grid below is the basic sine curve, y equals sine of x. So we could see, right, this is our basic sine curve. On the same grid, sketch the graph of y equals sine of x plus 3. Okay, so all that's going to happen is it's going to be this curve right here, but shifted up 3 units. All right, so let's just take all our points and shift them up 3 units. So if I take this point right here, 0, 0, and shift it up 3 units, 1, 2, 3, right, we'll wind up right here. Just do that with all your points, right? See this point right here? That is at pi over 2, 1. If we shift that up 1, 2, 3 units, it'll be right here. So just keep doing. Just shift all your points up 3 units. If I shift this point up 3, 1, 2, 3, I'm going to wind up here, and just keep going, okay? So I'm shifting all of my points up 3 units. And even, in the negative portion of the x-axis. So if I shift this up 3 units, 1, 2, 3, I'll wind up right here, and so forth. And then when you connect these, you should have a curve that looks just like the one below. Oop, not as neat as that, but just shifted up 3 units. So that's what happens when you add a number to the end of a function. All right, now if we take a look at number 19, all we're doing is we are subtracting a number from the end of a function. So what's going to happen is this is just going to be shifted down 2 units. So same thing, take each of these points, right? See this point? And just shift it down 2 units. Take this point and shift it down 2 units. And just keep going, okay? Do that with all of your points. I'm just shifting every point I see down 2 units. And when you connect it, you should have something that looks very similar to this curve up here. Right? Just everything's shifted down 2 units. Okay, so if you take a look at the examples on the next page, so now we are on page 12, I guess, of our packet, we're going to answer some questions. Now, I just want to point something out. These are 2 formulas, whether you're given a picture or an equation, that we want to memorize here. The maximum point on a graph is equal to your vertical shift plus the amplitude, whereas the minimum point on your graph is equal to the vertical shift minus the amplitude. Okay, so for example, I just pulled up a picture of one of the examples we just looked at on the previous page. So this number at the end is called our vertical shift, right? And we know the number, which in this case is technically a 1 in front of the sign, is our amplitude. So if we wanted to find the maximum, wouldn't the maximum, I'll write this here, be equal to the vertical shift, which we said is 3, plus the amplitude, which we know is 1. So our max would be 3 plus 1, which is 4. Now let's look at this graph. If we look at the maximum height, isn't it at a height of 1, 2, 3, 4, right here and right here? So that works out. Now we know the minimum is equal to the vertical shift, right, which we said is 3, minus the amplitude, which again we said is 1. Okay, we're just doing 3 minus 1. And since 3 minus 1 is 2, the minimum is equal to 2. So let's look. If we go up to 1, 2, isn't that the minimum height of our graph? Okay, so these formulas apply whether you're looking at an equation or whether you're looking at a graph. Okay, so let's just apply them to these examples where they give us the equations. All right, so if we want to find the maximum value, right, we know maximum is equal to the vertical shift plus the amplitude. Now again, the vertical shift is this number that's being added or subtracted to the end of your function, and the amplitude is the number in front of the sine or cosine. Okay, so if we were going to do the vertical shift plus the amp, we would have 5 plus 3, which would be 8. So 8 would be the maximum value. All right, now for the minimum value, it's really the same formula, except we use a minus sign. We do the vertical shift minus the amp. So that would be 5 minus 3, which is 2. Now the range just means how high and how low does it go. So if this is the highest value and this is the lowest value, right, our range goes from the lowest value to the highest value. And I'm going to put those in square brackets, okay? If you guys recall, when we do interval notation, square brackets means that these are included. And our graph is going to go from a height of 2 to a height of 8, okay? So if we were to graph this, it would fluctuate between a height of 2 and a height, and a height of 8. So it would, be something like this. Okay, so now why don't you guys try the same thing for 21, okay? And just a reminder, your vertical shift is this number here. Ooh, and be careful with this one, because look at this. What is our amplitude? Remember what we talked about amplitude. Amplitude always, it's really the absolute value of this number. It has to be the positive of this number. So our amplitude is equal to positive 7, not negative 7. When we're talking about height is a positive value. Okay, so try out A, B, and C and see how you do. All right, so for the maximum, we just do the vertical shift plus the amp. So 10 plus 7 is 17. For the minimum, we just do the vertical shift minus the amp. So 10 minus 7, which is 3. And then as far as the range goes, right, we know the range just goes from the lowest, the minimum value, which is 3, all the way up to the maximum value, which is 17. All right, so there we go. All right, now if you read number 22, this one you should be able to do on your own. Read what it's about, and all they ask you to do is to find the maximum and the minimum. So try it out. All right, so for the maximum, our vertical shift is 80, and our amp is 70. So if we do 80 plus 70, we get 150. And make sure you label the units, right? Because it is a word problem, so that would be feet. All right, so as far as the minimum goes, if we do the vertical shift minus the amp, so 80 minus 70, that would give us 10. Okay, so as this Ferris wheel goes around, it fluctuates from 10 feet all the way up to 150 feet. Okay, so take a minute and read number 23 and see what you can do with that. Okay, so the first thing they wanted us to do was state the maximum, right? And that's what I did here. The maximum is equal to our vertical shift plus our amplitude. So 2450 plus 250. So it's 2,700 milliliters. And they also wanted us to explain what this value represents. All right, well, we're talking about a person's lung capacity here. So you could, be straight to the point. A person's maximum lung capacity is 2,700 milliliters, and that's it. All right, so if you turn to the next page of your packet, page 13, we're going to continue to talk about shifts, but now we're going to talk about what happens when you add or subtract a number within the parentheses. Okay, now first of all, I'm looking on this page. Do me a favor. There's actually mistakes on this page. There should be parentheses around the x plus pi over 2, as well as the x minus pi. Now, if you think about, again, we've learned about shifts, right? We've learned about what shifts something to the left and what shifts something to the right. If you add a number within the parentheses, like we're doing here on number 24, doesn't that shift it to the left? Remember, it's the opposite of what you would think, right? So when you have a plus sign within the parenthesis, it shifts it to the left. So this is going to shift to the left, pi over 2 units. Okay, whereas when you have a subtraction sign within the parentheses, it's shifting it to the right. So this is going to shift to the right pi units. All right, so let's do it. All right, let's start with number 24. So we're going to shift, if we want to shift to the left, pi over 2 units, you're going to take each of these points. Okay, I'm going to actually start with this one. This one's at pi over 2, 1. So if I want to take this and shift it pi over 2 units, wouldn't that just be shifting it right here? So this point would wind up here. If I want to shift this point pi over 2 units, wouldn't it wind up right here? So basically what I'm doing is I'm taking each of these points and just shifting it, according to this graph, just one box over. So if I shift this pi over 2 units over, right, and just keep going. I'll shift this one box over and just keep going. Okay, and let's do it with the points over here as well. So if I shift, I'm going to shift, I guess I'm on this one. And if I shift this one box over, I'll wind up here. If I shift this one box over, I'll wind up here. Same thing here. I'm going to shift this one box over. Now, technically, we still need to put a point over here. And if you follow the pattern, we could see what it's doing, right? So wouldn't this point wind up right here? So there we have it. Now, what you may notice is that this equation, isn't that the same thing as our basic cosine curve? Right? So it gives us this gives us, when you take a sine curve and shift it pi over 2 units left, we wind up with the cosine curve. Okay, now let's do the same thing down here. This one, they want us to take cosine and shift it to the right pi units. Okay, so if I were to take this and shift it to the right pi units, wouldn't this point wind up pi units over? So really, according to this graph, 2 boxes over. If I were to take, let's say, this point and shift it pi units over, it's 2 boxes. So you're really just shifting each of your points just 1, 2 boxes over. And once you get the pattern of it, right, you could see our graph is just going to basically look like this. You don't actually have to count the boxes anymore. Okay, but if you want to, if I shift 2 boxes over, it winds up here. If I shift this one 2 boxes over, it winds up here. And again, if you're seeing the pattern, right, you can just keep going and follow the curve. So this is what it looks like, which is really just a negative cosine curve. Okay, so on the next page, we have our general format of any sine or cosine curve here. And it says what everything stands for. I'm going to actually label it on this equation. Okay, so A is our amplitude, B is the frequency, C is the horizontal shift, and D is the vertical shift. Okay, so use this information and see if you on your own, hit pause, can answer this first column right here based on this given equation. All right, so the amplitude is this number right here in front, which is 3. The frequency is the number in front of the x, which in this case is a 1. Now the period we don't actually get by looking at the equation, but we know the period is equal to 2 pi over the frequency. So 2 pi over 1, which is just 2 pi, right? Let's get rid of that 1 on the bottom. All right, now our horizontal shift is x minus whatever's here. So x minus pi over 2. So the horizontal shift is just the pi over 2, not the negative pi over 2, because the negative is built into the formula. So it's going to be pi over 2. Now, if you were graphing this, we know that if there's a negative sign in the parentheses, it means we're shifting it to the right. So this actually means we're shifting pi over 2 units to the right. Okay, and then the vertical shift is this number at the end by itself, so the minus 2. So this is going to be shifted 2 units down. All right, now let's look at the next column. These first 3 you should be able to do, right, based on what we did 2 pages past. So hit pause and see if you can figure these out. All right, so let's start with the minimum. The minimum we know is equal to the vertical shift minus the amp. So the vertical shift is negative 2. And from that, we want to subtract off our amplitude, which is 3. So the minimum is going to be negative 5. Okay, so our maximum is equal to the vertical shift plus the amp. So this time it's going to be -2 plus 3, which is +1. So that's our maximum value. Now, as far as the range goes, the range fluctuates between the minimum value and the maximum value. And because the graph is actually going to hit those values, we're going to put these in square brackets, meaning that they are included. All right, the midline, what that means is the midline is just the middle height of your graph. So if you think about the middle height of your graph, that's going to be midway between your minimum and your maximum. Then midway between your minimum and your maximum is always where your vertical shift is, at -2 in this case. So let me just give you the formula. The formula for your midline, here, let's put this at the top of our page. The formula for your midline is just y equals whatever your vertical shift is. Okay, so this is your formula for your midline. Now, because it's a line, okay, you have to write y equals. So it's just going to be y equals -2. Right, and that's it. So there's our answers for number 26. All right, try out 27, hit pause, and then hit play and see how you did. All right, so I just labeled what was what within the equation. So we know we have amplitude, frequency, horizontal shift, and vertical shift. So our amplitude is equal to +2. The frequency is also equal to +2. The period we know is equal to 2 pi over the frequency, and since the frequency is 2, it's 2 pi over 2. So then that's going to simplify, right? The 2's cancel to just pi. That's our period, right? That's the horizontal length of one complete cycle. All right, now be careful with the horizontal shift. Remember, the horizontal shift, the formula is x minus the horizontal shift. So x minus what gives you a plus pi? That would have to be -pi. And let me just explain that. Because within the parentheses, it's x minus the horizontal shift. So if we do x minus -pi, that's where that plus sign comes from, right? A negative times a negative is a positive, so that's where that plus sign comes from. So basically, for your horizontal shift, you're just going to have the opposite sign in there. Okay, and then as far as the vertical shift goes, that's this number that's just being added to the end of the function right here. So that is +1. Okay, so now as far as our minimum goes, right? Remember the formula for minimum. The minimum is equal to your vertical shift minus the amplitude. So since our vertical shift is 1 and the amplitude is 2, the minimum is just going to be equal to 1 minus 2, which is -1. All right, the maximum, on the other hand, is equal to the vertical shift plus the amplitude. So 1 plus 2. And that is equal to 3. So as far as the range goes, we know the range fluctuates between the minimum value and the maximum value. So our range is going to go from -1 to +3. And because the graph is actually going to hit those values, we want to put this in square brackets. That way we know that these values are included. All right, and then finally, the very last one here, the midline. Now remember, the midline is y equals your vertical shift. So since we know the vertical shift is at +1, the midline, right, the middle height of your graph is going to be at y equals 1. All right, and there we have it.